So, forget just visiting Mars. We're not talking about planting a flag and coming home. SpaceX wants to build a city there. This isn't just another space mission, you know? It's genuinely one of the most audacious goals in all of human history, and it's all about making us a multiplanetary species.
And there it is, right from Elon Musk himself. The key words here are self-sustaining. It's not about an outpost that needs constant resupply from Earth. It's about a permanent, independent human civilization on a whole other world. I mean, the scale of that dream is just staggering.
Right. But that's the billion, maybe even trillion-dollar question, isn't it? So let's really get into it. Let's take a hard look at the enormous gap between this incredible dream and the absolutely immense technical hurdles that are standing in the way.
First things first, before we even get to the rockets and the robots, we have to talk about the destination itself. Because Mars, well, Mars is not just some slightly colder, redder version of Earth. It's a fundamentally different and, frankly, hostile planet.
I mean, just look at how stark these differences are. It's night and day. We're talking about gravity that's barely a third of our own, an atmosphere that's not only paper thin, but it's almost pure carbon dioxide, and an average temperature that makes Antarctica look like a tropical beach resort. Every single thing we take for granted here, from walking to just breathing, has to be completely re-engineered for this world.
So, how does SpaceX plan on conquering this hostile world? Well, not with a single ship, or even a dozen. They're talking about an entire armada. And it's the sheer scale of the logistics where this plan goes from just ambitious to almost unbelievable.
The whole plan hinges on these launch windows that only open up once every 26 months. And look at this ramp up. It starts with 5 ships, sure, but then it escalates incredibly fast to hundreds, and eventually the goal is thousands of starships, all packed with colonists and cargo. Let's be clear, this is not an exploration mission. This is a planned mass migration.
And this number right here, this really puts the challenge into perspective. 1,200 metric tons of propellant for one ship. Now multiply that by the 1,000-ship armada we were just talking about. We're looking at a level of production and launch infrastructure that humanity has never, ever even attempted before.
Okay, so before anyone even gets a chance to step on that red soil, SpaceX has to solve a whole series of unprecedented engineering problems just to get there. The journey itself is the first gauntlet, and it starts right here in Earth orbit.
The very first problem is just basic reliability. SpaceX's Falcon 9, that's a proven workhorse. But as former NASA director Scott Hubbard points out here, Starship is it's nowhere close to that same level of trust yet. You can't exactly build a city on Mars if your ships can't reliably make it to orbit in the first place. And remember that massive propellant load we just talked about? Well, you can't launch it all at once. And this leads to one of the biggest technical unknowns in the entire plan. Starship has to be refueled in orbit. That is a massively complex maneuver that has never, ever been done on this scale.
So, here's the plan. It's this incredibly delicate dance in zero gravity. First, you launch your Mars ship. Then, you have to launch up to a dozen separate tanker flights just to fill its tanks. Each one of those has to dock and then transfer this supercooled cryogenic fuel. That's a lot of opportunities for something to go very, very wrong.
And that's the real problem here. According to former NASA engineer William Notardonato, this whole thing is pretty much just theory. Yeah, the computer models exist, but we have almost no real-world flight data for handling these kinds of cryogenic fluids in space. We don't even know for sure how much is just going to boil off and get wasted. It's a huge, huge question mark.
All right, let's just imagine they solve all that. The ships actually get to Mars. Well, that's when the real challenge begins. Trying to survive and build a home on a planet that is actively, constantly trying to kill you.
First up, you've got to land. But Starship isn't some small, squat little lander. It's a skyscraper, and it has to land vertically on a completely unprepared surface it's never seen before, all while trying to autonomously find a stable spot and avoid hidden boulders, soft sand, or unpredictable slopes.
And Scott Hubbard makes a fantastic point here. He brings up the recent lunar landers that tipped over. And remember, the Moon is a much friendlier place to land than Mars. Starship's tall, slender profile makes it inherently unstable on any kind of uneven ground. A single rock in the wrong place could literally topple the entire ship, and with it, the entire hope for that outpost.
So let's say you've landed safely. Awesome. But you can't just send humans out in spacesuits to start pouring concrete. The radiation alone is lethal. So that first most critical wave of construction has to be done by robots. They have to deploy all the essential stuff before colonists can even think about stepping outside.
Now, SpaceX's answer to this is its bipedal Optimus robot. It's a bold vision, for sure. But a lot of experts are, well, they're pretty skeptical. Bipedal motion is incredibly difficult even here on Earth. So on Mars, with its lower gravity and treacherous terrain, betting everything on an unproven humanoid robot could be a single point of failure. It's a huge gamble on a new technology when designs like the Perseverance rover are already proven to work up there.
And to build anything, you're gonna need power. Lots of it. And here we see a really fundamental difference in strategy. NASA's official plans, they rely on a compact nuclear reactor. Powerful, reliable, works 24/7. SpaceX, on the other hand, is betting everything on solar panels. And just look at the oxygen goals. SpaceX needs to generate way more propellant for the return trip, and that puts an enormous strain on their power system.
And here's what that choice means in reality. To make enough propellant for just one Starship to get back home, you would need a solar farm the size of about 7 American football fields. Now imagine having your unproven robots build that massive construction project on a deadly planet that's famous for planet-encircling dust storms that can block out the sun for weeks at a time. It's a tough problem.
So, with all of these monumental challenges laid out, what do the experts actually think? Is this a brilliant vision of the future, or is it just sheer fantasy? Well, as you can probably guess, the opinions are deeply divided.
On the one hand, you've got experienced veterans like Robert Moses from NASA. He looks at the plan, he compares it to NASA's own architecture, and he basically says, yep, the logic is sound. In his view, SpaceX is thinking about all the right problems.
But then you get a really sharp reality check from another expert, Robert Zubrin, who, by the way, is famous for being a huge Mars advocate. He is so certain that the timeline is impossible that he is literally willing to bet money on it. For him, the gap between the technology we have today and the goals they've set is just way too wide.
And maybe this is the most balanced take of all. You have Casey Dreyer from the Planetary Society, and he acknowledges all the incredible challenges, but he also reminds us of one really crucial thing. SpaceX has this wild habit of doing what everybody else says is impossible.
And so that's the question we're left with, isn't it? The dream is inspiring, the scale is absolutely breathtaking, and the challenges, well, they're astronomical. Whether this whole plan becomes humanity's crowning achievement or maybe a cautionary tale of ambition is a story that is still being written, and all of us are going to be watching to see how it unfolds.